All right, so I think I'm recording. Let's take a look at our solutions to some homework problems, Skill 6A Day 2, where we're simplifying radical expressions. So we want to simplify the square root of 24. And that's always the first thing you're going to do is look to see what kind of radical you have. Do you have a square root, a cube root, a fourth root? Because that's going to be the significant place to start. So then we need to break down 24. So let's come over here and let's break down 24. And what you kind of want to do is look to see if you can find the largest perfect square that divides 24, but you may not always see it. So if you do see it, 4 times 6 is 24. And 4 breaks down to 2 times 2. See, 4 is a perfect square, so we found a pair, and when you have a square root, that's what you're looking for, is a group of 2. Now, the 6, yes, it breaks down, but we don't have a group of 2. Now, we have a property of square roots that allows us to break apart the multiplication, so the square root of 24 is the same thing as the square root of 4 times the square root of 6. And over here in our scratch work, we just showed that the square root of 4 is 2. So here's our final answer, that the square root of 24 is equivalent to 2 times the square root of 6. Let's take a look at number 2. So remember from last time, the first thing that we want to look at is what type of a radical do we have, and this index of 2 is implied. This is a square root. So when we come over here to break down 147, we want to try and find perfect squares. Well, 147 is large enough, you may not be able to see the largest perfect square that divides 147, but we can see that it's divisible by 3. So, isn't it? Yeah. 3 times 49 is 147, and there's our perfect square, 49, because it breaks down to a pair here. So we know that the square root of 147 is the same thing as the square root of 104, or the square root of 49 times the square root of 3. And the square root of 49, we know that we have a pair of 7s as factors, so that simplifies to 7. So there's our answer for number 2. Let's move on to number 3. So again, when we see a radical, our first place to start is what kind of radical is it? Is it a square root, a cube root? And that is referred to as also referred to as the index. And when you don't have a number written here, the index of 2 is implied. Now, don't forget that you have a multiplier of 7 here, and I just think of it initially as just coming along for the ride. Now, for 80, we need to break 80 down and see if we can find a perfect square, the largest perfect square that divides 80, or break it all the way down to a product of prime numbers. 80 is 5 times 16, and 16 is 4 times 4. So I have a pair of 4s here. I know that I can rewrite the square root of 80 as the square root of 16 times the square root of 5. Now I can't simplify the square root of 5 because there's only a single 5 there. There's not a pair of 5s like over here there is a pair of 4s. So we have this 7 that's coming along for the ride, and the square root of 16 we know is 4 because that was the pair. Because when its index is 2, you're looking for a pair. And 7 times 4 is 28. So our answer for number 3 is 28 times radical 5. All right, so what about number 4? So again, when I'm simplifying these radicals, the first thing I always do is what type of radical do I have here? What's the index? Well, this is a 2. This is a square root, and notice that it's the opposite of the square root of 128. So this can be thought of as a -1, or just think of it as the opposite. You don't forget that needs to come along for the ride as well. For 128, let's break it down, and we can break it down to 2 times 64, and 64 is a perfect square because 64 is 8 times 8. So we have found a pair. We know that the square root of 128 breaks apart into the square root of 64 and the square root of 2. And we've just shown over here that with 64, we have a pair of 8s and times the square root of 2. If you didn't notice the 64, if instead, suppose your factor tree, when you got to 64, suppose you kept breaking it down because these are all even numbers. Well, that's fine. You're going to get the same answer that we do. It's just that your factor tree is going to be a lot longer. Might even run off the page. So if you count all of these up, 1, 2, 3, 4, 5, 6, 7, 128 is equal to 2 to the 7th power. So when you go to take the square root of 128, when you're trying to break this up, then you've got 2 to the 6th, 2 to the 1st. I can break apart because 6 plus 1 is 7. And now, when I look here to see how many groups of 2 do I have, if I write out 6 factors of 2, I'll have 3 groupings of three pairs. And a quick and easy way to see that is 6 divided by 2 is 3. And 2 to the 3rd power is 8, and that's what we have over here in our answer. Now remember, the negative sign was because within the problem it was a negative. But the square root of 128 I found up here in a factor tree, and my factor tree was much shorter. And down here, if I didn't notice 8 times 8, like I say, if I kept going by even numbers, my factor tree's longer, but I break it down and I get the same answer. All right, so let's do number 5. All right, in the first 4 problems, I've mentioned that the very first thing you should look at what type of radical you have, and here we have a cube root. So our whole thought process when we break this down is a little bit different. I'm going to go ahead and separate the cube root of 512 from the cube root of x to the sixth power so that I can focus on 512, that the x to the sixth won't interfere with that. So 512, well, that's a pretty big number. Let's grab a calculator and kind of play around with it and see what kind of. We know it's an even number, so we know if we have to that we can divide it by 2. But is there a bigger number? What about 4? Yeah, 4 works. What about even bigger than 4? What about like 16? Would 16 divide it? And 16 does. What about something like 64? Does it divide it? And it does. Let's start there. Let's recognize that, hey, 64 and 8. That 64 times 8, if I punch that in my calculator right, is 512. And right away, I have found 8. Now remember, I'm not looking for a pair. It's so easy because you get so used to doing square roots that you forget for a minute that you're not looking for a pair, you're looking for a group of 3. And so I just found it. I know that 512 breaks down to 8 to the third power. So if you're taking the cube root, you're looking for a group of 3 factors, and you have found it. 8 times 8 times 8. So this is just 8. So this middle, we've got this 5, and this middle factor right here is just a very ugly way to write the number 8. Now, what about this x to the sixth power? Well, 6 divided by 3 is 2. If you don't see that, then write out 6 factors of 3. Six factors of x, and group them in a group of 3 because the index was 3. So how many groups of 3 do we have? Well, here's one group, and here's the second group, and that's why that exponent is 2. And now don't forget that to multiply 5 times 8 is 40, and we have our final answer for number 5. And I don't think that you initially look at that and say, oh, that's 40 times x squared, but it is. It's not obvious at all, or at least it's not to me. All right, but they are this. Even though visually they look different, they represent the same number. They're the same. They're equivalent to each other. So again, if they're asking me to simplify a radical, the first information that I look at is what kind of radical do I have? Well, here I have a cube root. So, and here's something that I think that we saw in the previous video. When we have a negative symbol here, that negative symbol is just going to come out of this cube root as a -1. So why is that? Well, maybe here, let's break it down a little bit. With multiplication, we can break this down and say that negative is -1 because -1 times a positive 16 is -16. And then I have this variable p. So I can now focus on each of these individual cube roots and see if I can simplify it. So does the cube root of -1 simplify? Well, it does, because we're kind of going to do a trick here, that -1 is the same thing as -1 times -1 times -1. If you have an odd number of factors, that product is going to be -1. So even though we don't have a 3 here, we can put parentheses around that and say, hey, that's the base, that's the cube root, and the cube root of -1 to the third power is -1. Or you can just simply remember that every time you see a negative sign in an odd index, you're going to have a -1 in your answer. Now for 16, I'm going to have to break down 16. I'm not looking for square roots. It's tempting to say, well, 4 times 4 is 16. And yes, if it's the square root of 16, that's what I do. But I need to keep breaking this down further because what I'm trying to do is to find a group of 3. So I do have a group of 3 right here, but I have one left over. So I can break this apart and say the cube root of 16. I can say the cube root of 16 is the cube root of 2 to the third power times the cube root of just a single 2 right there. Now don't forget our cube root of p here. So why do I do that? Well, let's go ahead and multiply 6 times -1 right now to have a -6. Let's look at, we've said that, hey, this guy right here is easy because we have a group of 3. So when this index and that exponent are the same, that base is the answer. I have one group of 3 of these factors 2. Now, of the number 2. This cube root, this only has 1, so I can't simplify that any further. And over here, this p that we haven't looked at until now, it only has a single factor. So if I can take the cube root of some product and break it apart, I can also look at this and say, hey, if I have two radicals that I can't simplify and they have the same index, I can put them back underneath the same radical. So when I have this cube root of 2 and this cube root of p, I can write it as the cube root of 2 times p. And they do expect us to do that. And a -6 times a +2 is -12 times the cube root of 2 times p, and that's our final answer. What kind of radical do we have? Do we have a square root, a cube root? No, we've got a 4th root, all right? And it doesn't matter when we have multiplication, we can break apart that multiplication, and that sometimes will help us to focus our attention on something that's smaller and easier to work with. So 567. Well, that's a big enough number that I'm not exactly sure all of the factors of 567. So I have a calculator sitting here next to me. Let's see if it's divisible by 3. And it is. I come up with 3 times 189. Now, I'm not looking for a group of 2 or a group of 3. I am looking for a group of 4 because it's a 4th root. So let's keep breaking down 189. So let's see if there's another factor of 3 in there. Let's divide it by 3, and there is. So I've got 3 times 63. Well, 63 is divisible by 3. I can see that pretty easily, 21. And 21 is divisible by 3, 3 times 7. And look there, I have 4. I have a group of 4. And that's what I'm looking for with the 4th root. So let's come in, well, let's come over here. This 4th root of 567, don't switch the 6 and the 7, is the same as the 4th root of 3 raised to the 4th power, because see, I have 4 of these, that's why that exponent is 4. Now I only have 1/7, so times the 4th root of 7. I didn't have a group of 4 factors of 7, so that doesn't simplify. But this this is just a very ugly way to write the number 3, because you have one group of 3, so that 3 to the 1st power, and you can see that by saying taking the exponent divided by the index. 4 divided by 4 is 1. I only have one group of 4 things, and over here I have the 4th root of 7. So I've got this 3, don't lose it, and now this factor we just showed over here in our scratch work that that's 3 times the 4th root of 7. And when we look now at this variable, it's only x squared. We only have 2 factors. So it's not enough to simplify. We'd have to have at least 4 or more factors to be able to simplify that. So now we've got the right answer. We just need to put it in the correct form. 3 times 3 is 9. And they expect us to write this 4th root of 7 and to recognize that we can put the 7 and the x squared underneath one radical, because they never simplified. They never escaped from underneath this radical. And that's our final answer. Let's take a look at number 8 and see what we can do with it. What kind of a radical do we have? What's the index? When we're grouping things, how large does our group have to be? This is a 5th root, so we're trying to look for a group of 5 things. This 7 is just going to come along for the ride, and we're going to break apart this 5th root of 224 and this 5th root of x to the 3rd, and we can see now that the 3 isn't big enough, that this factor isn't going to simplify. So we do have to take 224 and come over here and break it down. So we know that it's divisible by 2, but is there any other bigger numbers? I don't know. What about 16? Is it divisible? Yeah, I just guessed another larger. 16 times 14 is 224. And I know that 14 is 2 times 7. And I know that 16 is 4 times 4. And now I've got 2 times 2 times 2 times. Look here, we have found a group of 5. Okay? And so we know that the 5th root of 224 breaks down to the 5th root of 2 to the 5th and times the 5th root of 7. And that 7, there wasn't enough of the 7s for us to simplify this radical. But this 2 to the 5th, we know that it has one group of 5 things, so this is one group of that 2. So that's why that exponent here is 1, or you can think this exponent 5 divided by the index, 5 divided by 5 was 1. And we have the 5th root of 7. So when we come back to our problem over here, we know now how to rewrite the 5th root of 224. We've got this 7 that's just coming along for the ride. We know now that the 5th root of 224 is 2 times the 5th root of 7 times the 5th root of x to the 3rd. And, well, 7 times 2 is 14. And here I can, since these have the same index, this is a 5th root and that's a 5th root, and neither one of them had enough factors to simplify, I can put that underneath one radical, and here I have it as the fifth root of 7 times x cubed. And that's our final answer. So I hope that helps. Ask me any questions as needed. I'm here before school and after school. Um, just let me know if you're coming in after school so I know to stick around a little bit. Talk to you later. Bye.